Welcome back to the Python programming specialization lectures. So in the previous lecture we have discussed some of the operators supported by Python like arithmetic operators, relational operators, logical operators and even the bitwise operators. In this video we will see in detail about some more operators that are supported by Python, the assignment operators, especially some special operators that are supported by Python. Those are the membership and the identity operators. So we will discuss all these operators in this lecture. So let us start our discussion with the assignment operators. So for assigning a value to a variable, so Python provides an assignment operator, so that is equal to symbol. So equal to is the symbol which can be used to assign either a value or a variable to another variable. So these are the general forms. So in the first form actually we are assigning a value to a variable, or you can even assign a variable to another variable, which indicates that you are assigning a value in another variable to a new variable. So in the third form you are actually assigning an expression, a complex expression also you can assign to a variable. So this is how you can use the assignment operator. So for example, a equal to 100. In this case I am going to assign 100, the value 100 to the variable a. So in the second case I am assigning an expression, that is a plus 1 is actually an expression, an operation, and that expression is evaluated first and then it is assigned to the variable b. In the third case c equal to a. So whatever the value that is available in a, that is assigned to the variable c. So not only the single assignment operation, so Python also supports multi-variable assignment. So that is, instead of assigning one variable using a single statement, so we can do multiple assignments using the single statement itself. So now let us see how we can assign multiple variables with the same value. So this is the general form we can use, where variable 1 equal to variable 2 equal to variable n, so on and so forth, equal to a single value. In this case, so whatever the value you are assigning, that value will be assigned to all these variables. So thereby all these variables will get the same value. So that's how, using a single statement itself, you can assign the multiple variables. Consider this example, a equal to b equal to c equal to 100. In this case the value 100 is assigned to a, b and c. So all these three variables a, b and c, they will get the same value, that is 100. So now let us see how we can assign different values to different variables using a single statement itself in Python. So Python supports that. So there are two different forms. So first consider the first form. So you can observe this general form, so which allows you to assign multiple values to multiple variables using the single statement itself. So variable 1, comma variable 2, comma variable 3, so on and so forth, variable n equal to value 1, value 2, so on and so forth, value n. So here what is happening is, so all the values that are provided on the right hand side will be assigned to the variables on the left hand side. So the respective values will be assigned to the respective variables. So value 1 is assigned to variable 1, value 2 is assigned to variable 2, so on and so forth, value n is assigned to value n. So consider this example, a comma b comma c equal to 100 comma 200 comma 300. In this case 100 is assigned to a, 200 is assigned to b and 300 is assigned to c. So that's how in Python it is possible to assign multiple variables with different values also. So in the last case we have seen how to assign multiple variables with a single value, and now we have seen how to assign multiple variables with different values. So now let us see the other form of assigning different values to different variables, and in this case simply we are concatenating all the simple assignments by separation of a semicolon. So consider this example, a equal to 10 semicolon, b equal to 20 semicolon, c equal to 30. So here we are simply combining all the individual assignments, simple assignment of the values to the variables with a separation as a semicolon. So a gets 10, b gets 20, c gets 30, it's quite obvious. So that's how Python supports assignment. So not only the single value, single variable assignment, so multiple variables also can be assigned with same value or different value using the single statement itself. So now let's see how Python supports various shorthand assignment. In shorthand assignment, what happens is, so Python allows us to mix an operator with the assignment operation. So you are merging an operator together with the assignment operation. So consider this example, A equal to A plus B. So this is equivalent to A plus equal to B. So instead of using two different operators as in the first statement, we can achieve that using a single operator, that is plus equal to. So both results in the same value itself. Either you can use A equal to A plus B, which means that you are evaluating A plus B and then you are assigning that to A, or otherwise in the second statement what you are doing is A equal to A plus B itself. So both designates the same kind of operation. So now let's see what are the various shorthand operators that are supported by Python. Of course, so it supports various shorthand operators like plus equal to, minus equal to, so asterisk equal to, slash equal to, modulus equal to. Like for all the arithmetic operators it supports the shorthand operators. In addition to that, for the bitwise operators also, for all the binary bitwise operators also, it supports the shorthand assignment. So let's see the usage. Usage is also the same. Whenever you are using A plus equal to B, that is equivalent to A equal to A plus B, or simply instead of writing it as A equal to A plus B, you can shortly write it as A plus equal to B. So for all the arithmetic operations you can use that, or even for the bitwise operations also you can use these shorthand formats, which makes your code more readable and more compact. So far we have discussed various operators that are supported by Python. Actually all the relational operators, assignment operators, arithmetic operators, so these are the operators that are supported by all the other languages like C, C++, Java, C#, even in many other languages also. So it's very common to use all the other operators, but Python supports two special operators, so that are allowed only in Python. So for the flexibility of the users, so those are identity operators and the membership operators. So now let's see how we can use the identity operators. Identity operators are basically used to compare the identity of two objects or the variables. That is, whether two variables or two objects are having the same value or the same object or not. So if they are having the same object, pointing to the same object, then the returns are true, otherwise the returns a false value. And to check the identity of the objects, Python supports two operators, that is and not is. Operator object2. So that is, I can use to check whether A and B, two variables are pointing to the same object or not, I can use that as A is B. And whenever you are using is and not is, they return the Boolean value true or false. So basically every object created in Python is given a unique integer ID to designate the memory location of the object, and this unique ID can be returned by Python by using the method ID. And by using these is and not is operators, whether they are pointing to the same object or not, we are going to check. So whenever we are using the is operator with variables, then it checks whether they are pointing to the same objects or not. So A is B. In that case, we are basically checking whether A and B are pointing to the same object or not. If it is so, then it returns a true value, otherwise it returns a false value. And not is works in exactly the opposite to the is operator. In case of A not is B, what happens is when A and B are pointing to the same objects, then it returns a false value, otherwise it returns a true value. So that's how we can use the identity operators to check whether the object variables are pointing to the same objects or not. So now let's see the examples. We need to know a few other details. So A equal to 300 is an assignment operator. So what happens when we use this assignment operator is an object is created with the value 300, and for that you are assigning the name A. So that's what is the meaning of an assignment operation in Python. So basically every item of data is treated as an object in Python. So even an integer, a string, a character, a floating point value, so anything is treated, even a function is also treated as an object in Python. So Python is a strictly object oriented programming language. So by an assignment operation, it means that you are creating an object in the memory location and then you are giving a name A to this object, right? And now I am going to assign this A to the variable B. In that case, what happens is, so you are giving another name to the object. 300. In that case, when I check, because A and B are pointed to the same object 300, so that's how when I use is operator to check the identity of these two objects, A is B, obviously it returns true as they are pointing to the same object. So that is how A is B works. So now let's see this example where A equal to B equal to 300. I am using the multivariable assignment in this case. So the 300 is assigned to both A and B together in the same instruction itself. So obviously here also your object 300 is created in the memory location, and then you are giving the names A and B to the same object itself. So that's how A is B, so it returns a true value. It's very obvious in this case also. So now let's see another example. So A is 300. So that means you are creating an object in the memory location and you are giving a name A to that. And now B equal to 400. Obviously a new object 400 is created for you and you are assigning a name B to that object 400. Of course 300 is an object, 400 is a different object. Both are different objects and A and B are the variables which are pointing to two different objects, and when you check the identity using the is operator, A is B, obviously it returns a false value only. So now consider this example, A equal to 100 and B equal to 100. So of course I am assigning the same value to both A and B, right? That is, so we assume that the same object is created and you are assigning the different names to that, and that's how A is B is returning true. But quite interestingly, when I do this, A is equal to 300, B equal to 300. So I am assigning the same value here also. But when I check the identity of these objects, it's returning a false value. So what is the reason for that? We need to understand that, right? So in the first case, I am assigning 100 to different variables in different statements, A equal to 100, B equal to 100. And when I check A is B, it is returning a true value. But whereas in the second case, A equal to 300, B equal to 300. So in that case, I am assigning the same value to two different objects, but in that case it is returning a false value. What could be the reason? So the reason is simple. So what happens is Python interpreter basically creates integer objects in the range of -5 to 256 at the very beginning of the execution itself. So that's how in the first case, in the first example where you are assigning two different variables with the same object also, so already that object is available and so your name will be given to the same object itself. That's how A and B are pointing to the same object 100. That is how A is B is returning a true value. But whereas in the second case you are assigning 300, so that's how they are treated as two different objects itself, as Python did not create those objects at the beginning, and whenever you are creating two different variables, they will be treated as two different objects only. That's how this identity are different and it's returning a false value. So now I hope it is clear how you can check the identity of different variables and what makes their identity. Now let's see how the membership operators can be used. So another special operators that are supported by Python alone, unlike the other programming languages. So let's see how we can use these membership operators. Basically these membership operators are used to check the membership of an element in a sequence. So to support that, Python provides two operators, that is in and not in. So these operators also return the Boolean value, that is true or false value, depending on whether the presence or absence of the element in the sequence. Now let's see the general form. So in can be used as, so element you are checking whether the element is present in the sequence or not. So you can use it as element in sequence. So if the element is present in that sequence, then in that case it returns a true, otherwise it returns a false value. So here I mean sequence means it could be a list, it could be a string, it could be even a tuple or a dictionary or even a set. Now not in also can be used to check the presence or absence of an element, but it works exactly the opposite of the in operator. So whenever you are using an element with the not in operator and check whether it is available in the sequence or not, then in that case it returns a false value whenever the element is present in the sequence, and it returns a true value when the element is absent in the sequence. That's how we can use. Now let's see how we can use with various sequence data structures. So first let's see how we can use the in operator with the lists. So a value as 10, I am treating that as an individual element, then L as a list. In this case I am going to use check whether A is present in L or not. I can simply use A in L. Of course, 10 is present in the list L. You can very well see that, and that's how it's returning a true value. But in the second example, I am going to check A not in L. Actually, A is present in L, but you are checking for not in. That's how it returns a false value. As it is present, not in returns a false value. Whenever it is not present, then it returns a true value. So now let's see how we can use the membership operators with the tuples. So similar to how it works with the list in membership operators can also work with the tuples. A equal to 10, and I have taken a tuple with a collection of elements 1, 3, 5, 7, 10 and 12. I am going to check whether element 10 is available in T or not. A in T. Of course, the element is present, so it is returning a true value. So A not in T, of course it's present, so it's returning a false value. The working is all the same as the list. Now let's see how the membership operator can be used with the dictionaries. When I use it with the dictionaries, actually it checks for the element's presence as a key in the dictionary, so not as a value. So that's what we need to remember here. So it checks for the presence of the element as a key, not as a value. So consider this example, A in D. Here A is a value 10 and 10 in D. So 10 is not present as a key in the dictionary D. That's how it is returning a false value. But whereas 1 in D, it is returning a true value as 1 is present as a key. So first element itself, first element's key is 1, and you are checking for that 1 itself. So that's how it is returning a true value. And similar to the list and tuple, we can use membership operators with sets also very well. So here I am going to check whether the element 10 is present in the set yes or not. Of course, the element 10 is present, so it's returning a true value. Again, I am checking 1 is present in yes or not. So directly I can use a constant also to check with the identity operators. Of course, 1 is also present, so it is returning a true value. That is how membership operators can be used with various non-primitive data structures like lists, sets, dictionaries, tuples and strings. So far in this lecture we have discussed various operators, like how do we use the assignment operators. Along with that, what are the shorthand assignment operators, then the identity operators, and the criticality of how the identity of an object is decided we have discussed in depth. And moreover, we have discussed special membership operators that are supported by Python. Now I hope you understand all the details about the operators. So now you can make use of various operators that are supported by Python in your applications for your usage. Thank you for listening to this video.